Okay, moving on to 7.6. Before we do the questions, I'll go over some concepts. The first thing that you need to know is a sample space. So the sample space simply lists out all the possible outcomes. Is a list of all possible outcomes in a probability experiment. I can give you an example. Let's say the experiment is just tossing a coin. Our sample space. So usually we use this set bracket. This is a special bracket called a set bracket to contain the possible outcome in the sample space. So our sample space from tossing a coin will just be head or tail. So those are the possible outcomes. And then, so sample space is the first thing that we need to know. The total number of possible outcome in a sample space equals to the number of possible outcome in event 1. So event 1 could be just tossing a coin times the number of possible outcome in event 2. And then, you can just keep on going depending on how many events there are. So we can toss a coin. So that could be the first event. And then rolling a dice. That could be the second event. So tossing a coin, you have the possible outcome is just head or tail. Rolling a die is going to be 1, 2, 3, 4, 5, 6. Right? On a 6-sided die, the possible outcome will be from 1 to 6. So here we have 2 possible outcomes, and here we have 6 possible outcomes. So we are going to have 12 possible outcomes in total. You can list out the combined sample space quite easy. It's just like distributing. You can have head and 1, and then head and 2, and then you can just keep on going. Head 3, head 4, head 5, head 6. You can also have tail and 1, and then tail 2, tail 3, tail 4, tail 5, and tail 6. Okay, so the key is you need to know that the total number of possible outcome in the sample space. You just need to ask yourself how many possible outcomes are there in each event, and then you just multiply them. You also need to know how to make a tree diagram. So the example is, let's say there are 3 children in a family. So this time, our first event is either a boy or girl. The second event, so the second child is also either a boy or girl. And the third child is also either a boy or girl. So in order to list out all the possible outcome, we can use a vector tree. So we can have boy or girl. That's the first child. And then the second child could be boy or girl. And the third child can also be boy or girl. So whenever there are more than 3 events, if you really want to list out all the sample space, tree diagram is definitely the way to go. When there's only 2 events, you can do what I did earlier, just distributing, or I'm going to show you a two-way table. So how do we read this outcome? We can have boy, boy, boy. I can start writing out my sample space. It can be boy, boy, boy. It can be boy, boy, girl, meaning that the oldest child is a boy, second oldest is a boy, and the youngest is a girl. We can have boy, girl, boy. We can have boy, girl, girl. And then I can continue. We can have girl, boy, boy. Girl, boy, girl. Girl, girl, boy. And girl, girl, girl. So using the shortcut way, we should know that the total possible outcome, total number of possible outcome in our sample space should be 2 times 2 times 2, right? Oldest child can be boy or girl. The second oldest can be boy or girl, and the youngest can be boy or girl. So if we multiply them, we should get 8. So we can verify this. This is 1, 2, 3, 4, 5, 6, 7, 8, right? So we have 8 total possible outcomes. That's the tree diagram, and then you also need to know the two-way table. Remember the example that I gave earlier? The first event is just tossing a coin. So you could have head or tail as the possible outcome. And then rolling a die. The outcome is 1, 2, 3. 4, 5, 6. So we can have head and 1, head and 2, head and 3, head 4, head 5, head 6. Right? This is just head and 1. That's why it's H1, head 1. And then we can have tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. And there. So now we have all the possible outcome. Head 1, head 2. So next you need to know that the probability of some event E is going to be the number of outcome E divided by the total outcomes in the sample space. So going back to our 2 example, I could ask what is the probability of having maybe at least 2 girls? In a family with 3 children, right? Well, I can go back to my tree diagram and look at my sample space. This is my tree diagram and my sample space. So we have two girls here, boy, girl, girl. We can have girl, boy, girl, 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 boy. So those are two girls, at least two girls, and of course I can also have three girls, right? That's what they mean by at least two girls. So we have four favorable outcome or four outcomes that satisfy having at least two girls, and out of we have 8 total possible outcomes, right? So we have a 1/2 chance of having at least two girls. We can also go back to the other example. What is the probability of head and odd number, something like that, head and odd number. So we can go back to our 2A table. So we want head and odd. So H1, H3, and H5, those are head and odd. Out of how many total possible outcomes? Well, the total possible outcome, if you just count, you will see that there are 10, because that's 5, and that's another 5. So in total, we have 10 possible outcomes. So the probability of getting head and an odd number from tossing a coin and rolling a dice is 3 out of 10. Number 6, the probability of some event E will always be in between 0 to 1. So if the probability of E equals to 0, it means that it will never happen. For example, I can say what is the probability that Terry is on Mars right now. Well, right now I'm in Vancouver. So this probability of Terry being on Mars right now would be 0. And at most, you can just have 100%. It just means that this event is certain to happen. So it could be, what is the probability that Terry loves math? And this is 100%, because I already know I love math. Okay, and those are all the concepts that you need to know. Now we can move on to do the questions. I'll see you in the next video.